Article 404.9 of the National Electrical Code addresses the grounding requirements for switches. This section specifies that switches must be grounded and connected to the equipment grounding conductor where one is provided. However, there is an exception to this rule. The exception states that if a switch is connected to a metal box using metal screws, it's considered grounded through that connection. This means that under specific conditions, a separate grounding conductor might not be required for the switch itself. To understand this better, let's break down the key components. Firstly, the term grounding in electrical systems refers to intentionally creating a low impedance path from electrical equipment to the earth. This path allows fault current to flow safely back to the source, causing overcurrent protection devices like circuit breakers or fuses to trip and to energize the circuit. This, in turn, protects people and equipment from electrical shock and damage. Secondly, an equipment grounding conductor is a specific wire within an electrical system that connects the non-current carrying metal parts of equipment, such as metal enclosures and boxes, to the grounding system. Its purpose is to provide a low impedance path for fault current, ensuring that the circuit protective devices operate correctly in the event of a ground fault. Thirdly, bonding is the process of connecting all non-current carrying metal parts of an electrical system together to create a continuous electrical path. This includes metal conduits, metal boxes, enclosures, and equipment frames. Bonding ensures that all these metal parts are at the same electrical potential, minimizing the risk of electric shock. Article 404.9 is quite specific. It states that the switch must be mounted to a metal box. This metal box must be part of a properly grounded electrical system. The connection must be made with metal screws, ensuring a reliable electrical connection between the switch and the metal box. When these conditions are met, the metal box effectively becomes the grounding conductor for the switch, and a separate grounding conductor for the switch might not be necessary. It is important to emphasize that simply having a metal box does not automatically satisfy the grounding requirement. The metal box itself must be properly bonded to the electrical system's grounding electrode system. This means that the metal box must be connected to the equipment grounding conductor, which ultimately leads back to the grounding electrode, such as a ground rod or a metal water pipe, at the service entrance. The reasoning behind this exception is that a properly bonded metal box provides a sufficiently low impedance path to ground. If a fault occurs within the switch, the fault current will flow through the metal screws into the metal box, and then through the equipment grounding conductor back to the source. This rapid flow of fault current will cause the circuit breaker or fuse to trip quickly to energizing the circuit. Without this grounding path, a fault could cause the metal parts of the switch and the metal box to become energized, posing a shock hazard to anyone who comes into contact with them. There are several factors to consider when determining whether or not a separate grounding conductor is required for a switch in a metal box. Firstly, the type of wiring method used. If the wiring method includes an equipment grounding conductor, such as a metal conduit or cable with a grounding wire, then the metal box will typically be grounded through that conductor. In this case, the switch is considered grounded when mounted to the box with metal screws. Secondly, the condition of the metal box and its connections. The metal box must be in good condition, free from rust, corrosion, or other damage that could impair its conductivity. The connections between the metal box, the equipment grounding conductor, and the switch must be tight and secure to ensure a reliable electrical path. Thirdly, local codes and regulations. Local electrical codes and regulations may have additional requirements or restrictions regarding the grounding of switches. It is crucial to consult with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Some jurisdictions may have stricter requirements that mandate the use of a separate grounding conductor for all switches, regardless of whether they are mounted in a metal box. It is also important to remember that this exception only applies to switches. Other electrical devices, such as receptacles and light fixtures, typically require a separate grounding conductor, even when mounted in a metal box. The National Electrical Code provides specific requirements for the grounding of these devices, and it is important to follow those requirements carefully. It is recommended to always consult with a qualified electrician or electrical inspector if there is any doubt about the proper grounding of electrical equipment. They can assess the specific situation and provide guidance on how to ensure compliance with the National Electrical Code and local regulations. Ignoring grounding requirements can have serious consequences, including electrical shock, fire hazards, and equipment damage. Proper grounding is essential for electrical safety and should never be taken lightly. To summarize, under NEC Article 404.9 bone, a switch mounted to a metal box with metal screws is considered grounded, provided the metal box is properly bonded to the electrical system with an equipment grounding conductor. A separate grounding conductor for the switch itself might not be necessary in this specific scenario. However, factors such as the wiring method, the condition of the metal box and its connections, and local codes and regulations must be considered. When in doubt, always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. Furthermore, it is important to understand the broader context of electrical grounding and bonding within the National Electrical Code. The NEC provides comprehensive guidelines for establishing a safe and effective grounding system. These guidelines cover various aspects, including the selection and installation of grounding electrodes, the sizing of grounding conductors, and the bonding of metal parts. Article 250 of the National Electrical Code is dedicated to grounding and bonding requirements. This article covers a wide range of topics, including grounding electrode systems, grounding conductors, equipment grounding, and bonding. It provides detailed information on how to establish a safe and effective grounding system for various types of electrical installations. Understanding the requirements outlined in Article 250 is essential for anyone involved in electrical work. It helps to ensure that electrical systems are properly grounded and bonded, minimizing the risk of electrical shock and fire hazards. In addition to Article 250, other articles within the National Electrical Code also address specific grounding requirements for different types of equipment and installations. For example, Article 430 covers the grounding of motors and motor control equipment, while Article 500 covers the grounding of equipment in hazardous locations. It is important to be familiar with these specific requirements to ensure that all electrical equipment is properly grounded. Moreover, it is also important to consider the role of ground fault circuit interrupters, or GFCIs, in electrical safety. GFCIs are designed to protect people from electrical shock by detecting ground faults and quickly interrupting the circuit. They are typically required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. While GFCIs provide an important layer of protection, they are not a substitute for proper grounding. Grounding is still necessary to ensure that fault current can flow safely back to the source, causing the circuit breaker or fuse to trip. GFCIs and grounding work together to provide comprehensive electrical safety. In conclusion, the exception provided in NEC Article 404.9 bone regarding the grounding of switches in metal boxes is a specific case within the broader context of electrical grounding and bonding. A thorough understanding of the National Electrical Code, including Article 250 and other relevant articles, is crucial for ensuring electrical safety. Always consult with qualified professionals and adhere to local codes and regulations to maintain safe electrical installations. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Improper electrical work can be dangerous and can result in serious injury or death. Always hire a qualified electrician for any electrical work that you are not comfortable performing yourself. Consider the different types of grounding electrodes permitted by the NEC. Common examples include ground rods, metal water pipes, and concrete encased electrodes, also known as UFA grounds. The selection of the appropriate grounding electrode depends on factors such as soil conditions, the availability of a metal water pipe, and local requirements. Furthermore, it is beneficial to understand the concept of impedance in grounding systems. Impedance is the total opposition to current flow in an alternating current circuit, and it includes both resistance and reactance. A low impedance grounding path is essential for ensuring that fault current can flow quickly and effectively, causing overcurrent protection devices to operate promptly. High impedance grounding systems, on the other hand, are sometimes used in industrial applications to limit the magnitude of ground fault current. These systems require careful design and coordination to ensure that they provide adequate protection. Consider the importance of regularly inspecting and testing grounding systems to ensure that they are functioning properly. Grounding connections can loosen over time due to vibration, corrosion, or other factors. Regular inspections can help to identify and correct any problems before they lead to a safety hazard. Ground testing, such as using a ground resistance meter, can be used to verify that the grounding system is providing a low impedance path to ground. It is also helpful to keep up to date with the latest revisions to the National Electrical Code. The NEC is updated every 3 years to reflect changes in technology, industry best practices, and safety concerns. Staying current with the latest NEC requirements is essential for ensuring that electrical installations are safe and compliant. Many resources are available to help electricians and other electrical professionals stay informed about the NEC, including training courses, seminars, and online publications. Moreover, consider the role of arc fault circuit interrupters, or SIs, in electrical safety. SIs are designed to protect against fires caused by arcing faults, which are dangerous electrical faults that can occur in damaged or deteriorated wiring. SIs detect the unique characteristics of arcing faults and quickly interrupt the circuit, preventing a fire from starting. The NEC requires SIs in many locations throughout the home, including bedrooms, living rooms, and hallways. While SIs are not directly related to grounding, they provide an important layer of protection against electrical fires. Additionally, consider the impact of harmonics on grounding systems. Harmonics are unwanted currents and voltages that can be generated by nonlinear loads such as electronic devices and variable frequency drives. Harmonics can cause overheating of neutral conductors and equipment grounding conductors, and they can also interfere with the operation of sensitive electronic equipment. Proper grounding and bonding practices can help to mitigate the effects of harmonics. It is also helpful to use harmonic filters or other mitigation techniques in installations where harmonics are a concern. Reflect upon the importance of proper labeling and documentation of grounding systems. All grounding connections and equipment should be clearly labeled to identify their purpose and function. This helps to ensure that electricians and other personnel can easily identify and maintain the grounding system. Documentation such as grounding system diagrams and test reports should be kept in a safe and accessible location. This information can be valuable for troubleshooting and maintenance purposes. Keep in mind that the specific requirements for grounding and bonding can vary depending on the type of electrical system and the application. For example, the grounding requirements for a residential electrical system are different from those for an industrial electrical system. Similarly, the grounding requirements for sensitive electronic equipment may be more stringent than those for general-purpose electrical equipment. It is important to consult with qualified professionals and to refer to the appropriate sections of the National Electrical Code to ensure that the grounding system is properly designed and installed for the specific application. The information provided here is not exhaustive and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical inspector for any electrical work. Electrical safety is paramount and should never be compromised.